Hello and welcome back to the channel, and in today's episode I'm going to show you how to recreate Pacman in Godot 4. It's going to be rather complex, and also it's not going to be like a perfect copy of the game because the complexity of that game is actually quite big. But nevertheless, we're going to work with some AI and navigation, with animations and time maps to recreate the game at least to the state that can give you some satisfaction. Yeah, it's gonna be pretty complex and pretty long, so let's get right to it. Okay, so to build our Pacman game, we have to create a few things, and we'll start by creating a new project. I'm gonna find the proper place for it. I'm gonna create new folder and call this Pacman underscore tutorial and select current folder, render forward version control metadata git. Create that. And first let's go to 2D because our game is gonna be 2D and check some settings. So first let's search for clear color and we will switch it to black to have that black background. And next setting, we'll go to settings and then input map and set our input map for our movement. So left is A, right is D, down is S, and up is W. Okay, then let's find rendering, display window, and we will change our mode to be viewport, and that's correct. And I'm gonna create new scene, and I'm gonna just get empty node, call this main. That's what I typically do. So let's create new folder, call this not assets but scenes, save it. Okay, and now what we will do is we will bring all the assets that we need for our game to assets folder. You can find these in oops, it didn't import well, in the GitHub, which is linked in the description below. Okay, let's go very quickly through our assets. The font that we'll use for some really minor UI stuff. Fruits, basically in the Pacman, you have that fruit spawning, which when eaten give additional points to the Pacman. I'm not gonna incorporate that functionality in our game because this is just a minor addition and the tutorial itself is gonna be long enough. Ghost textures, the map, sorry, and this is actually really interesting because if you take a look, or maybe let me open it like that, you have different maps for different Pacman games. We will be recreating this map. I attach this file into the GitHub because it is a good reference. As you can see, each and single part is being set on a grid, right? So this is really good as a reference whenever you're building this maze. Okay, Pacman and Pacman animation, pellets, the sounds, and the walls. And as you can see, the first set of images is the images of the walls. Each is a separate part of the wall, And then we have the atlas, which is, let me show you, the texture atlas that I created. If you would like to create that kind of atlas, what you would have to do is to click on all the parts of the atlas as separate images. So from 0 to 37, then go to import tab, import as texture atlas, and specify the name. I'm gonna just add test here, and then do re-import, right? And I believe that it should work. Yeah, it should be there. What it is there. What we need to do is to can you refresh this somehow? Yes, here it is. Right, so that's how you create the texture atlas. Let's delete this because this additional stuff. Okay, and what we have to create first is our tile map and our tile set. So I'm gonna add child node. I'm gonna create tile map. There's no tile set there, so definitely something that we will have to change. So let's create new tile set. Okay, you can see it already appearing here and also here. And we need to set the tiles. No tile source selected, select or create tile set. Okay, so what we have to do is to bring our wall atlas and this time up, this is tile set. And just drag and drop it here. Yes, I would like to create tile sets, and as you can see right now, the size of the tile set does not correspond well with what's in our atlas. So first things first, let's go click on the tile set in the tile map in inspector and change the tile set to 24 by 24. And then we have to change the texture region in our tile set to be, I believe, 32 by 32. And now I can grab that tile in a tile map. Remember, tile set is just the configuration of your tiles. Tile map is where you actually do some kind of painting. I can select it, and as you can see, I can start drawing, which is really, really cool. Okay, before we do all that, let's start by setting up our camera. Okay, so let's add a chart, camera to D, position it on 0, 0, 0, but I'm gonna zoom it a little bit, and I found that 0.812 is correct value for me. Okay, so basically now my job is to use the proper tiles to recreate the tile map here. Okay, so that's what I'm gonna be focusing on. Yeah, I'm gonna speed up the part when I'm drawing the tile map because it's gonna be rather boring. Yeah, I'll see you after the tile map is done. Okay, so this is the tile map done. I hope I did not make, no, I did some mistakes, but if you do, you can always drag and move it. Just use the cursor to select something. I have to check whether we have one cell span everywhere, and it does look correct. As you can see, this is a rather complex process. I also was referencing this again a lot to make sure I'm drawing this correctly. And also I use these patterns for some kind of repeated figures in our maze just to speed up the process a little bit. Again, this is not throughout basic beginner tile map tile set tutorial, but if you'd like me to create one, I'm definitely up to do this. So yeah, we have our wonderful tile map, and it's time to add our player. So that's going to be the next section, adding the player and the movement, encoding the movement. Okay, so with our tile map done, I think we're ready to start working on our player. So I'm gonna add a child node and search for character body 2D, rename it to a player, and I'm gonna save branch as a scene, go to scene, name it, actually let's name it Pacman. Okay, and let's open that, and we will start adding stuff to it. We need a collision shape, but to present that we first need to add the sprite. Let's search for a sprite 2D, and then in Pacman we can find just maybe Pacman 2, looks about right. Okay, cool. Let's see, do we need anything here? I'm gonna change the scale to be -1. Let's go here, and first you can see that the sprite is blurry. This is rather typical with the pixel art used in games, but you can solve that by going to texture, filter nearest, and now it's automatically clear. Basically, yes, let's turn it left. I don't know why, it's just in the game it looks like the Pacman is starting left. Also, I try to recreate most of the game based on the free Pacman game. So looking stuff up, I was trying that game. So go to freepacman.org if you'd like to try it. Okay, then we have information that we need collision shape. So collision shape, and then we need a shape which is going to be circle, and we need just to set the proper radius. So here I'm going to change this to 7 pixels, and this looks about right. Okay, this in itself is enough for us to start coding. So let's add the script. Let's call this Pacman. We can get rid of basically everything. And let's start by adding class name. Why isn't, let's switch the seems that my keyboard is messed up. That was interesting bug. but I couldn't press C. Okay, let's find class name. Name it player actually. Okay, let's add a speed. Actually, let's make export var speed. Okay. And we will have to write some stuff. First things first is that we have to handle the collision with the tilemap. So we have to have additional set of information on our tilemap. So let's go here. Let's find layers. Is this correct? Oh no, go to tile set and let's find the physics layer, and we have to add the element, and we're gonna set it to 2 and 1, and then we have to actually paint the collision on each of our sets so that we know how to collide with each part of our tiles. So go to tiles, go to paint, property, physics layer. Yeah, and that's gonna take a while to properly paint, but basically what we're doing is we are drawing how our Ghost and Pacman should collide with each tile. It's gonna take a while, but let me just give you an example. I'm gonna select this one, and you can manipulate and add and edit the points to match your needs. What I'm going to do is enable snapping, and I'm going to enable grid snap, and I'm going to set the grid density to 42, or maybe in that case 16 is going to be better. And let me just manipulate those points correctly. Yes, so what I'm going to do now is I'm going to write the collision on each tile so that our Pacman can properly collide with each single tile, and it's gonna take a while again. So what I'm going to do is I'm gonna speed up this part of the video, but you will see me just adding, manipulating, changing, maybe removing some points just to match the collisions that we need for our game. So yeah, I'm gonna check with you after this is done. Okay, and this pretty much set up the navigation for our time map. What we also have to do is actually configure the layers so that they make sense. So let's go to settings. This is going to be, I believe, 2D physics. Yes, so layer first is going to be the player. Second one going to be the wall. Then also small pellet and big pellet. Okay. The second one means wall, and then we also have to click on our player collision, and we say that it exists on the layer force but can collide with walls and pellets. We should probably also go at ghost, but we'll see about that. Yeah, cool. So now that we should be able to to hit the walls when and if we move. So in the next section of that video, we'll actually write the code for the movement of our player. Okay, so let's code the movement for our player, and we will need some variables. So let's add movement direction. And let's start this as vector 0. Can I actually, maybe I can make it easier for you to read. Okay, cool. And let's do physics process. Okay. And first thing we're going to do is we will get the input. Yeah, get input, and we're gonna create a separate function for that to handle the input. If input is action pressed left, movement direction is equal to vector 2 left, and we also have to set the rotation. The rotation degrees is equal to 0. Else action pressed right, movement direction is equal to vector 2 right, and the rotation is set to 180. Then we do down. Movement direction is set to vector 2 down, and the rotation degrees is equal to 270. Input is action press up. We set the movement direction to 90. No, sorry, we set the rotation degrees to 90, and we set movement direction to vector 2 up. Yeah. And then what we do is we set the velocity to movement direction times speed. That's correct, and we call move and slot. Okay, we have the player, the script is attached. Let's see. Oh, and of course we set the main main scene to be the main scene. Okay, and as you can see, we are already colliding properly. The problem is, of course, the size of our player. So let's go to 2D, and let's first change the scale of our player here. And I think that 3.42 was the value that I have chosen. And then also the position. The position, and it should be actually below, like here. So this should be, let's see, center is here. I believe this should be good. Let's try and see. Yeah, we have the Pacman going around our maze, so this is cool. Maybe a little bit junky on the edges, but we can fix the collisions later. But at least we have that. The problem is that in our Pacman game, this is not the actual movement, because what is happening is once you press, you can like set the next movement direction, and it's gonna move when it finds the span between the walls. So, and if you take a look at the free Pacman game that I mentioned previously, you understand what I'm talking about. Like, as I'm moving down, I can press left here, and it should continue moving down and then automatically go left once there's a span between our walls, right? So this is something we can also add. So to do that, let's open our player, and we're gonna extend it a little bit. I'm gonna add something called direction pointer, which is gonna be another sprite. Direction pointer. Okay. Let me see, and I'm gonna position it. I'm gonna start with the texture. So in Pacman, I have the direction pointer. Cool. Let's change the texture filter to nearest. Set the transfer to 0.2 and 0.2. Delink it. Okay. And then the position, let's see, about here should be good. And as you can see, this is pointing to the direction of the movement of our Pacman, right? So where will it move next? Okay, so we have to code this. Let's see, we need a reference to direction pointer. So let's say we're gonna keep the variables here. Say variables, then say export variables, and then say on ready variables, so that we can keep it clean. Okay, let's drag and drop to get the path, but drag, hold control and drop to get the onReady variable. Cool. And we will also need the programmed direction, so that's going to be next movement direction, which is going to be vector 0. So how is this going to work? Basically, what we have to do is, once the new movement is programmed, right? Let me use my favorite tool for this. Okay, so we have a wall, and we have a span, and we have our Pacman, right? So once we program new movement, we have to query every single frame whether the move in that direction is possible, right? So Pacman is gonna move that way because that's gonna be his current movement direction, but we're gonna query in that direction to see whether there's a wall. And once there's not, we're gonna switch the direction to move between the walls. That's pretty much it. So what we're gonna need is we're gonna need the shape query to query. Basically, this is like raycasting. Physics shape query parameters to D. Okay, and we're gonna use that to query and raycast against our walls. Let's see. So if in our get input, one thing that is going to change is we're going to use next movement direction here, and then let's see, we get the input and let's check if current movement direction is equal to vector to 0. If it is, then the movement direction, this is just to get us started, is next movement direction. And then we have to check, can we move in direction of the next movement direction and pass delta here. And if we can move in that direction, then the movement direction is the next movement direction. So basically we have to write that function. Let's see, function can move in direction. Vector 2 and delta is float. I can add the typing just to help myself. Return bool. Okay. So shape query transform is going to be equal to global transform translated direction times speed times delta times 2, just to move it a little bit further. That's why we're multiplying by 2. And then we're gonna query. So result of the query we can get from get work to D, direct space state intersect shape query, and check whether we have some results. So check for the size because that's an array, and if there's no wall here, then the size is gonna be 0. Float flow at okay. Yeah, and that's pretty much it. You actually need the reference to the direction pointer. Yeah, we will need it later. But for now, that should be enough to program our movement. Let's see. And it doesn't work at all. So oh, and I can see in the debugger there's an error. Condition not shape is true, returning 0. Okay. Oh yes, because we have to prepare the query. So let's do ready function, and here we have to prepare some stuff regarding our shape query. So the shape is going to be the collision shape. So let's get that, and that's gonna be collision shape. Shape query collide with areas is equal to false. Shape query collide with bodies is equal to true. Shape query collision mask is equal to 2 because we're querying against walls. I don't know whether we need those actually. Maybe let's get rid of those for now. And no errors. Oh, now it works. Okay. So I'm gonna go down. I'm gonna press right and then press up immediately. Nice. Now we can schedule our movements. This feels great. So yeah, this is basically the movement of our Pacman. Great. So in this next section, we are going to go a little bit off track, and we're gonna actually handle navigation because it's gonna help us set the pellets properly. We will be coding just in a while the AI for our ghosts, and our ghosts have to have the ability to move through the empty tiles, and we have to specify how they should do it. So since we're working with our tilemap already, we can go to it, and let's see, we have to create navigation layers in the inspector right here. It can be left on the first layer, and then in our painting properties we have to go to the navigation layer. Okay, and we only want our ghosts to move through empty tiles. So what we will need actually is to create alternative layers, because based upon how the tilemap looks, right? We have to specify how the ghost is able to move through a given empty tile. For example, right here it can only go left and right, and here it can go up and down, but also left. So we have to specify this. So let's select our first empty tile, and we're gonna create the most reusable tile, or the tile that is covering the most of the cases. So basically what we're trying to do here is to set the lines right in the middle. Right, I can maybe zoom up a little bit more. Now let's see. Okay, this feels like it is in the middle, and then we also have to change it a little bit to also add left and right. So edit, you have to add a point here and maybe here, another point here. Well, what we're going here for is a cross. So add a point here and here and here, drag it. This feels like it's a little too big. I'm going to be aiming to make it as thin as possible. Here and here and here and here. Drag this to the middle. Drag this. Okay, let's see. Yeah, and this is our first tile. Again, this is very repetitive work. You already know how to add it, and now what I will be doing is I will be adding alternative tiles to basically take into account all possible navigations. So yeah, I'm gonna add this, and I'm gonna get back to you after I'm done. Okay, so this is our navigation painted, and again, it might feel a little bit like off track. We should be working and setting the palettes right now, for example. Let me create one additional, but it's gonna make sense just in a second. Okay, cool. And now we can go to our Tilemap, search for navigation visibility, and I'm gonna say force show. And now we can set up the navigation for our ghost. So let's go to Tilemap, tiles. The only problem is that we have to guess a little bit which is what, because it's not showing the navigation right here, but we can figure it out. So let's try, let's try painting. Okay, cool, it paints. So for example, if I take a look at this tile and this tile, basically you have to check how the ghost can move through here. Let's find the horizontal and vertical ones first. This is also vertical. This is vertical. This is horizontal. And this is going to show the paths on which our ghost can move. This is correct. And then here, this is vertical and horizontal. Here is gonna have a different shape. Basically, every single how do you say it, conjunction? Like every single tile where the ghost can turn will be a little bit different. Okay, this and this and this. Okay, so now if you make a mistake, don't worry, you can right press to cancel it. This isn't correct. This isn't correct. Should be here. Fix that. I'm gonna just try and leave the empty spaces where we have to, oops, update the location. I mean the navigation tile. Here and no, that one. Here. Okay. Here. This is a turn. Oh, I deleted something. That one. Cool. This is a turn. This is empty. Turn, empty, empty. Turn and empty. Turn, turn. This. Remove this, remove that, remove that. Okay, now it's only time to fill the turns. Let's check our tile set. Okay, this is like all sides. So here, 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 and I think that's it. This is like only left turn. And I have to remember that. So, oops. Here. And here. Okay. Next one is the upturn. Here and here. Here and here. Here and here. Oh, also here. That's what I missed. Here and here. Then we have the downturn. Here. Here. Here and here. And this is the upturn. I'm trying to remember which tile is where. Nope. Nope. Yes. Let's see, left turn is 1, 2, 3. Here. Okay, then we have up to right. Oops. Which is, oops, I screwed this up. No worries, we can fix it. Then let's rotate this. Flip. Yeah. Okay. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Here, 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 and the next one is right to down, so it's gonna be here, here, here. Don't worry if you miss a spot, we can always get back to it later. Okay. Also, I believe we're missing another type. So flip. Okay. You can basically speed that part up. Okay. Then we have, see, left to bottom, and this is free from the end here. Here, 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 and here. Okay. Let's see, left to up. Oops. Oh no, why? Damn it. Here, here. This is pretty much done. Okay. This is not what I want. Let's see. It feels like we're missing something. Okay. 1, 2, 3, 4. 1, 2, 3, 4. Here. Okay. And here is the last one. A bottom. 1, 2, 3, 4, 5. Here. Here. Okay. Also need like from bottom to up. That's gonna be and do we have that one from bottom to up? I think like we're missing a few. Oh, this is duplicate that. This should be okay. And then this, oops, this one. Oh, it screws up on the Tilemap. We can fix this. One, two, three. Nope. Okay, and then let's connect. This is all good, pretty much. 1, 2, 3, 6. No. I want to select. Okay. Fourth one goes here, here. And we have that. Okay. Then we need this one here, and we need this one here, and then opposite here. Okay, and the top is finally pretty much done. Still missing this one, so this is from, okay, so we need to flip it vertically and then flip it, no, flip it vertically, yeah, cool. So now top is done. Let's go to the bottom. We need, no, this and this, this and okay. Oops. This. Okay, few missing pieces. This and nope. Now I'm just guessing. Okay, this one, this one, this one. Okay. Yeah, it seems that our navigation layer is pretty much done, and it's very good because it's gonna help us in the future. We can now set up our pellets, and that's what we're going to do in the next section. Okay, so in this section we are going to create and place our pellets. So I'm gonna add a node here, and that's gonna be just a simple empty container node. I'm gonna call this pellets, and I'm gonna create new scene that's gonna be area 2D, and I'm gonna change it to pellet. Yep, we can save this, and it's gonna have a sprite 2D, which is going to be yeah, let's add a palette for now. For this, remove that. Gonna be let's see, palette medium, I believe. Okay, let's change the texture to nearest. Cool, and then we can set the collision shape. Let's add this rectangle, should be good. Okay, cool. So this is our palette scene, and then we'll also have large palette, which is different palette, the one that Pacman eats to give himself a superpower and eat ghosts. So let's create new area 2D. Let's save it as a large palette. Add a sprite, which is going to be large palette. Set the texture to nearest. add a collider. And also rectangle should be fine. I believe this is quite all right. Okay, and now what we can do is inside of our palette, we can add a child node, and add a child. It's gonna be a pellet, and you can see it here. And just to make sure we are placing them precisely, I'm gonna click on the tile map to see how to place these. Also, I'm gonna reference the map that we have here, just to make sure we're placing the pellets where they're supposed to be. Okay, cool. I'm also gonna check against the free Pacman game. And let's see. Okay, so there are places that have pellets, and there are places that does not have any pellets. So basically, yeah, we're gonna adhere to that. And we have to place our pellets in correct places. So yeah, they should be separated by, let's see, by how much. This is pretty much in the middle, so let's check the transform. -80, 12. I believe this should be -12. So every 24 pixels. Okay, that at least is some information. So I'm gonna place the pellets right now, also the big pellets. The distance between them should be 24 pixels. Again, this is very repetitive, very tedious work, so I'm just gonna pause for now and place them in the right places. So I will speed this up in the recording. Okay, and that pretty much sets us up when it comes to the settings of the pellets. So I'm gonna go ahead and place the pellets in the right places. So again, this is very repetitive, very tedious work, so I'm just gonna pause for now and place them in the right places. So the settings of the pellets. yeah, I think that's it. It doesn't have to be pixel perfect, and we don't have to place every single pellet. But with that, in the next section, we can start working on the interaction between our player and the pellets. So yeah. Okay, so in this section, we're gonna handle the eating of the pellets for our wonderful Pacman. So since this is going to be the location of our Pacman, I think we're gonna get rid of those two pellets, this one and this one, and then let's go to a scene and attach script. Palette is a good name, and then we're gonna create a class name. Call this palette. We're gonna reuse a script both for small and big palette. So I'm gonna add a var here, should allow eating ghosts. And what we're going to do is we're going to, and we'll default that to false. And we're gonna check our node here, and we're gonna override body entered. So connect that. We can check if body is a player, and we're gonna emit a signal here whenever the pellet is eaten. So pellet eaten, and we're gonna pass a pellet here. We're gonna pass self here because we will need that to determine which pellets have been eaten after we like reset the game whenever Pacman dies. So we're gonna go pellet eaten, emit self, and also we're gonna call QE3. Okay, and there's one thing we should also do. We should probably add to do here. Add interaction with player class to enable eating ghosts. So it's gonna be like if should outing ghosts, then we should do something here. Okay, that looks good. We'll also have to attach the same script for the large pellet. Oops, not here. Here, of course. Okay, and the only difference is going to be that this should allow eating ghosts. Cool. So now whenever we interact, yeah, you can see that the pellets disappear. Oh, and it seems that we're missing a part of the tilemap here. So let's fix that real quick. I'm gonna close this, go to the tilemap, to D, and here I go to the tilemap and find the missing part, just this one. Cool. Perfect. Yeah, and that's how we can eat our pellets. So in the next section, we're gonna probably add the animation, the basic animation for our Pacman. Yeah, cool. Okay, so for adding the animation to our player, we have to open the player scene, go to add child and add animation player. I'm gonna create new animation. I'm gonna call it default. And let's see, at the time of the animation should be 0.45. We're gonna make it loop. And then we will start by adding a track. It's gonna be property track, sprite 2D, texture, and we need to add keys. So there's gonna be 3 keys, 0, then I believe 0.15. So let's add this. Let's set the time here to 0.15, and next one 0.3. Perfect. So here I'm gonna add the full Pacman. Then then I'm gonna go and add this one, and then this one, and let's play it. Yeah, I believe that's good enough for our case. So now going here, we have to get the reference to our animation player. So this is onReady variable. Let's drag, remember to hold Control, drop it, and basically we can just play this onReady. So animation player, play default. Let's see. Yeah, that looks nice, right? It's gonna look even better if we go to Tilemap, go to navigation and set to default, which should disable it. Yeah, that starts to look like Pacman. Okay, the next thing that we should add is for the Pacman to teleport through this corridor, right? Because when he gets here, he should be teleported there. So let's try and code it right now, or actually in the next section. Yeah. Okay, so let's create that teleport feature. I'm gonna go to main, I'm gonna add new node, empty node. I'm gonna call this connector. And we need some things here. So basically, actually, you know what? Let's change the type and let's make it node 2D so that it has location. Right, I'm gonna check the location and put it in the middle, 0, 0. That's perfect. Actually, I can see that our time map isn't really symmetric. Should we care about that? I would have to select all of that, and then also select the time map, and then put it here. Yeah, we can live with that. Okay, cool. So now we have the connector, which also is in the middle, or almost in the middle, but that's good enough. And we can start adding stuff to it. So I'm gonna find color rect, because we will use that to give that effect of our wonderful Pacman teleporting like partially. So I'm gonna place it here, change the color to black, of course. Let's see, the layout, the transform, there is the size. So 20 and 50 or 45 maybe. Good, that should be good enough. And then we're gonna, so I'm gonna say this is like the right color rect, and then we're gonna duplicate it, move it across, and I'm gonna call this left color rect. Okay. So now we have to add the area to D for both. And we need to add the collision shape. Collision shape. And here also collision shape. Let's add the shape. That should be rectangle. It should basically match this one. So let's move it a little bit. Let's set the shape. Well, yeah, that's good enough, I think. Right. Or actually, maybe we should make it, yeah, a little thinner than the color rect. Yeah, that's good. And then here on that side, also add a new shape, make it rectangular. Let's set the size correctly here. Okay, cool. And now what we can do is we can add a script to it. Let's create new script called this connector. And let's get the references to our left and right area to D. So we're gonna need this. I'm gonna call this right area and then left. Perfect. We need to connect the methods here. So let's go to a node, and for both we need body entered and body exited. So connect to, let's close this here. Actually, let's disconnect. We have to name this properly. So that's left. So on left area body entered. Oh, places in the, you know what, let's save branch as a scene and then do the connection. So body entered on right area body entered, then body exited on right area body exited, then left. So here we have on left area body entered, and also need on left area body exited. Okay, cool. So basically we need to move our Pacman from one place to the other whenever we enter one of those areas. So for right area, we have to check. Basically, we have to check our velocity, right? So if body, we're entering the right connector, let's use our paint, of course. So here's the right connector, here's the left connector, here's the Pacman. So if here is going to the right connector, do we have to check the velocity? Maybe, right? And when he hits that area, we have to set his position from here to here. Okay. So let's try this the simplest way possible. Body position X should be changed to left area to D, global position X, plus maybe left area to D. Can you find the size? Let's stay with this for now. And this is right, and on the left we should switch it to the right. Okay, let's see, we're going here, and yeah, we're hitting both areas, right? So it doesn't know, and it's in the loop, right? So it's gonna teleport back and forth. So what we could do is check the transition direction. So let's say allow left transition is true, and then allow right transition is equal to true. And if we go to the left, to the right, we set our left transition to false, and here we say allow right transition is false, and then when we exit, we set allow right transition to true, and allow right transition to true. Okay, is it better now? Still not correct. Let's see. So to fix that, we could add one more check. Basically, we will allow transition in given direction only with the velocity of the body matches the proper direction. So if body velocity x is greater than 0, then allow the transition, and here also if body velocity x is less than 0, allow the transition. And that should be our connector done, I hope. Yeah, as you can see, we can teleport, and I can see this little artifact of us clipping through, but I'm gonna guess this can be fixed by simply looking at our wonderful color rect and changing the layout. So let's do the 40. And let's move this a little bit. and that here, and the same is gonna happen here. So set it to 40. Okay, and that's gonna cover that additional part here is gonna cover the clipping side, or at least so I hope. Yeah, that works well here. Here we probably have to move the area closer, move back a little bit. Still, I can see a bit of clipping. Let's move the area even slightly closer here, just to trigger the teleport a little bit faster. Yeah, now it's good. Yeah, and we can have this feeling of teleportation, right? Cool. Yeah, and that's how we write our connector. Yeah, so I guess I see you in the next section. Okay, so I believe the next step for us is to work on the UI and the game state. Meaning, if you take a look at our game right now, we of course don't have the enemies, the ghosts, but what we can do, let me place it correctly here, is to add the winning state, meaning when all the pellets are eaten, we can present some kind of UI informing the user, the player, that hey, you've won the game. So let's try and work on that. Basically, what we will need is we'll need to add a script to our pellets. I'm going to call this pellets manager. I don't like the word manager in the programming because it doesn't really mean anything, but we can work with that for now. So yeah, basically what we need to do is to get the information about all the pellets. So let's do it like this. We need information about total pellets. So total pellets count. And we also need information about pellets eaten by our wonderful Pacman. And for start, that's going to be 0. Okay, and on ready function, we can get a reference to all pellets, and that's going to be self get children as array of area 2D. That should be correct. And then what we could do is get the total pellets count, and that's going to be pellets size, right? And then for pellet, new pellets, we can iterate through the array, say pellet body entered. We could basically we could actually say that's a pellet, right? And then pellet eaten, we can connect to it, and we will say on pellet eaten, right? And then we have the information about pellet here. But do we need it here? Not sure. We'll see. We'll see for now. Okay, so let's think? Actually, I think that we actually don't need the information. We can get rid of it. So we can just emit without passing self. The simpler, the better. And then pellet eaten, we will do some stuff. We will increase the pellets eaten to 1, and we have to check if pellets eaten is equal to total pellets count. Then we can say that, well, game is won, right? Because that's the end of it. So basically we'll pass right now, but we need to take a look into some kind of simple UI to display that information. So let's, in our main, let's create a canvas layer, and right off the bat, let's save this as a scene, call this UI, open it. We're gonna add a margin container, and we're gonna add like, we're gonna spread across. So go here, click that. Now it spans across whole screen. Let's say 16. Okay. And also we're gonna add a center container. In that center container, we're gonna add a panel. And we're gonna go to custom minimum size, set this to 300 by 200. And we need to override the theme a little bit. Let's create new style box flat. A background color, let's make it black, but then we need to set the border to be white. Border width, I believe that 4 should be good. Okay, and corner radius, we could do something like 8. Okay, and that's the base of it. And then basically what we could do is add a label here. Center it. Let's say game label. And here we're gonna say game 1. And we're gonna change the theme here, meaning the font, and we'll create new theme. And we're gonna change the font. Okay, now it looks better. The problem is we have to change the texture to nearest. Let's see, vertical alignment center. This is good. And we should probably change the font size to something like 30 or maybe even 40. Cool. Okay. And of course we don't want to show it right off the bat because expected to organize palette eaten connect on palette eaten, of course. Let's try this again. Yeah, it shows right from the start, so we have to hide it. So let's hide the center container. And we have to attach a simple script to our UI. So let's create that. Let's get, we can give it a class name, because why not? And let's get the reference to the stuff that we need. So the center container and game label. Do we need game label? No, not really. Center container is enough. And I'm going to create a function, call it game1. And I'm going to say center container show. that's gonna be it for now. Go back to our main, and now our pellets have to get the reference to our UI. So how can we do this? We could export, and that's not the script, but that's another. We could export, or we could connect this directly. Let's do this directly. So rename this to UI, control drag, drop it, perfect. Now I can just say UI, we should cast this game 1. Okay. Let's quickly check whether this actually works. So this is me eating all the pellets. Oh, there's a problem, right? Because for some reason I cannot eat the big pellet. Let's see. Let's click this, and this shouldn't exist. Small pellet, big pellet. Okay, so we have to change that. No, this, and this can interact with player, and this is a big pellet. Okay, we have to change the collision. Okay, and for all other pellets, click them, and they exist as a small pellet. Okay, let's try this again, and it still doesn't work. Okay, so let's go here. This has a script called pellet. Body is a player. Let's print the body here. See what we're dealing with. Yeah, this is a player, and let's clear the output. And here, for any reason, it doesn't work. And this is probably due to the fact, if you can see here, we have the signal connected icon. We did not connect any signal from here. So let's go and take body entered. We have to find this and connect that. Yeah, and do the same for the others. Oh no, I made a mistake. I connected the wrong one. So let's disconnect. So area to D, body entered, connect. Find the area to D. Yes. The same should be here. Yes. And correct. And correct. And now should be able to eat the big pellets. Yes. So that was missing. Cool. Let's try and eat all the pellets very quickly. Let's see whether our game 1 works. And yeah, game 1. Perfect. So yeah, now we can win our Pacman game. Cool. So what should be the next step? I believe that in the next section we should actually start working on the most difficult and most important part of our game, which is riding our enemies, our ghosts. So I will see you there. Goodbye. Okay, so in this section we're going to start working on our ghost. And our ghosts have few behaviors like chasing Pacman, scattering, running away from Pacman, and returning home. The most basic behavior, the starting behavior that we're going to work on is so-called scatter, right? If you'd like to know more about the behavior of the ghosts, I will try to link in the description the article describing them. And again, I'm not gonna mirror the behavior of each ghost like it is in the original game, because they differ. They're, even though they seem very simple, they're rather complex. They have their own algorithm for the navigation. We're gonna try and keep it simple for the purpose of that tutorial. So basically what we have is a ghost, right? That when the game is starting, basically he's going through a set of points for amount of time. Then when the timer runs out, he goes and he searches for our Pacman, and he's trying to chase him and touch him. So we're going to start our work with ghosts by trying to implement the navigation and scatter behavior. Okay, so let me hold this, and we will start by creating a child node, and I'm gonna use just a simple node, and here I'm just gonna group all the ghosts, right? So first gonna be the red ghost, which is starting outside of this home area, and he goes around left upper corner, I believe. Okay, so let's try doing that. Let's create new scene. And this is going to be area 2D. I'm just gonna call this ghost. And we will start by adding two sprites. So first is the body sprite. And yeah, let's save this. And the second is the sprite for eyes. Eyes sprite. Okay, let's try and set it up properly. So the texture, let's find it here in the ghosts. Ghost body 01. This is good enough. And then for the eyes, we can just use eyes down. Okay, and if we set the texture to filter nearest, we will get our ghost, even though he's not colored yet. Okay, cool. We will have to set few things here. So let's start maybe by adding the collision shape. Collision shape 2D, and let's see. Capsule seems like a good choice. So let's try and set it up. Yeah, it's almost goes down to a circle, right? So maybe let's go like this. This should be, let's see, the height. Actually, let me check. This this should be, no, the circle is gonna be fine. So let's switch that to a circle and let's set this to 8. That should be good enough. Okay, cool. This is the basics. What else do we need? We need navigation agent, which is gonna handle our navigation. Perfect. And basically we could start coding. No, we need something else, right? We need a set of points that our ghost should work around. So let's add the ghost first. So instantiate ghost. Let's give him the starting position. I believe we should scale it up a little bit. So let's set the scale to 2. Okay, that looks better. And the position, something like 0 and -72 should be good enough. Okay, and we need to set the movement targets for our ghost. So where should he go? So let's create another empty node. Let's put it up here. I'm gonna call this movement targets, and I'm gonna say that I will add another node, and this is red ghost, and then these are the scatter targets. Cool. And here now we can set the scatter targets for it. So he should go like here, then here, then here, then here. So there's a cool node that you can use called marker 2D, which is very useful because it's really well visible in the editor. So let's set this marker, let's call this red 1. Let's duplicate it and let's start moving. So then he should go here. And then he should go here. And then he should go here. Perfect. But what I would like to do actually is not pass those movement targets directly, because we will have different ones for different goals. I would rather use resource. So let's create new folder for this resources. Right. And here I'm gonna create new resource. Empty resource is good. And I'm gonna call this red movement targets. Perfect. And we will also need a script here to stash those targets. So create new script, and I'm gonna call this movement targets. So this is basically like a scriptable object in Unity, somehow like that. Basically, you can externally store data in those resources. Okay. So, yeah, the script. Let's get rid of everything. This extends resource. Let's export scatter targets, which is going to be a set of array node 2D. Basically, that's going to be marker, but you know, we have the hierarchy of nodes. Marker is a node. And also we will have a different set of targets. That's going to be at home targets. So there's going to be different state, but we can write this now. Okay, and then here in red movement targets, we need to be smart and attach that script. So script, quick load, movement targets, and now we can add this. So the size is 4, and we can go to 2D and start assigning. So or even we could do assign and search for red 1, red 2, red 3, red 4. Perfect. So now we can go to our ghost and start adding the script. Okay. So what do we need here? We need the movement targets, obviously, and we need the speed. Export bar speed. So yeah, that's gonna be like 120, for example, but always adjust to match your needs. Movement targets. That's gonna be our resource. Okay. The question is, can we add a class? I don't think we can, but that's fine. Then also, what else do we need? I believe that should be fine for now. And we need references. So already we need definitely the navigation agent to allow the movement. So this is good. Let's see. Okay, let's start setting everything up. So function ready. Navigation agent 2D, path, desired distance, and this is 4. Nav agent, target, desired distance, and this is 4. Navigation agent 2D, target reached. We'll connect to that to get because when we reach one scatter point, we need to move to the next one. So let's create the empty function for now. Okay. Okay, this is cool. And then we can just call deferred setup. We'll create that function, and we need to call this deferred to get the navigation time to kick in. Okay, let's see. We also need the reference for the navigation map. So we need a reference to the time map. So let's do export. Tilemap is a tile map. Okay, and then what we can do in setup is nav agent set navigation map time map get navigation map 0. So that should be good, and then we need to access navigation server 2D agent set map navigation agent get RID time map get navigation map 0. Again, this might be a little bit complicated, but again, this is a tutorial about making the game, not the basic of the navigation. but this is basically the setup that we need, all of this to make the navigation work. Cool. Let's see. And after we have here, after we have that, we need to basically, let me see. We need to set the target position. So I'm gonna create a function and I'm gonna call this scatter because it's gonna handle the scatter state. And I'm gonna say nav agent target position, because we have to set the target position, is equal to movement targets scatter targets. So we're accessing our research current scatter index position, because every time we need to create that current scatter index, because every single time we reach new position we need to update it. Scatter index. And what I mean by that is that go to 2D. This is the scatter target, which has the index 0. When we reach it, we need to provide the new movement target for the navigation agent with the index 1, 2, and 3, and then just go in a loop, right? So this is our navigation agent. We provided him with a tilemap with the navigation, because you remember that there's a navigation for our tilemap, right? So we did that, and then we asked him to move to the first scatter target and then move in a loop. Let's get back to it and try to set it up. What else do we need? It's not gonna move yet, of course. So let's see. On position reached will be something interesting for us. Okay, so on position reached, let's see. If current scatter index is less than 3, I believe, because that's the amount of the scatter targets, current scatter index plus equals 1, else current scatter index equals 0, and else. Okay, so we just switch the current scatter index, and we also need to update the target position. Okay, so now whenever he reaches the position, he should switch to the next one. Let's see. We also need a process function. And here we'll call move ghost, and it's gonna use nav agent get next path position, and we'll also need to pass delta. So let's write that function, maybe here. Yeah, move ghost. It's gonna take next position to move to, which we get from the navigation agent. This is vector 2, and we get delta, which is float. And you can see that sometimes I'm providing the types for functions, sometimes not. Well, GGScript is very liberal about it, but whenever I would like to get the information about the type of arguments, I just pass those. Okay, so current agent position or current ghost position is equal to global position. Let's see, new velocity is next position minus current agent position, current ghost position, sorry, normalized times current speed times speed times delta. Okay, and we can just call position plus equals new velocity, and we're moving it by hand by updating the position. Are we missing something here? Let's see where this crashes and burns. So let's go to main. We have our ghost. Let's get rid of that. Movement targets, we have to assign that. So we can just drag and drop it, and Tilemap, drag and drop it, and let's see. And it doesn't move. Okay. Let's check what's wrong. Of course, what I forgot was to call the scatter after we finish the setup. And with that, we have our ghost moving through our scatter targets. Hey, this is perfect. Okay, so in the next section, we're gonna enhance our ghost a little bit. We'll add the animation, add the eyes will be changing, and we'll add the color. So yeah, let's get to it. Okay, so let's enhance our ghost a little bit, and we will start by allowing to set the color for it. So here I'm gonna export color of that color, and then in our main I'm gonna call this red ghost. You can set the color to be red, and we need to apply this. And to do that, we have to have the reference to the body sprite. So let's add that. We're in a ghost, cool, body sprite. And we can now in ready body sprite we actually need a reference there. Well, basically we can make it a little bit smarter because we don't need to care about that. We can add attach new script here and call this ghost body sprite, and we can get the reference to parent. So I can just do this and this. Let's see, remove the reference for now, maybe we'll bring it back later. But here we have the information about color which is in our parent. Let's add a class name, class name, and this is ghost. Cool. And then here you can say self moderate is equal to get parent as ghost color. Okay, and why are we doing this like that? We could of course store all of that code inside of sprite script, but I really encourage you not to throw every single functionality into single script, because it's gonna get messy, it's gonna get big, and it will be hard to read and hard to change. So I'm trying to split my functionality, split them across nodes that actually should work given way. For example, I know that the sprite should change its color and not the area 2D, right? I hope that makes sense. Let's see whether that works. Yeah, we have our red ghost now. So this is first thing done. I'm gonna go here and disable the navigation in the Tilemap so that just looks a little bit better. Cool. And now for the animations, right? So let's add an animation player. Animation player. Let's see. And we will add very simple animation called default, or maybe moving. That also sounds nice. At the time, it's gonna be 0.5. The track's gonna be property track body sprite texture. We will add one key here and one in 0.25. Cool. And we'll just switch the texture here. So if you go to the assets, ghost, change it, and we'll have that moving notion. Yeah. And we're gonna just trigger this also in body sprite. So let's get the reference here. Oops, hold control. Put the reference to the player. And we'll do animation player play moving. Okay. Does it actually play? Oh, we forgot to turn on the looping. So we can change the interpolation to cubic, turn on looping, and now, yeah, we can see the animation playing. Perfect. Okay. Last thing I wanted to do in that section is to change the eyes, right? And we can add another script. So our script, and we call this how do we call this ghost body sprite? So this is going to be ghost eyes sprite. Cool. And what we'll do is we are going to create lookup table, so like a dictionary. We'll call this direction. Well, actually no, first we need to create export group. So export group, and we call this I sprites, and we export up sprite, which is, well, we know it's a sprite, right? So it's texture beam. So let's call this properly eye textures. So what we will get is a set of grouped up exported variables to which we can assign eyes, because if you take a look at this, we have eyes down, left, right, up. So we need to assign this export var left texture to theme, export var right texture to theme. And then to close the export group, you just export empty group. And now here we have this all grouped up. And you can drag and drop the sprites that we need: up, right, and left. Cool. Basically, what we need to do is to change the sprite that we display every single time that the direction of our sprite changes. So we also need a lookup table, because it's gonna be pretty simple and pretty cool. So lookup table, you can just say that the keys are down and the value is down texture. Oops. For up direction, the value is up texture. For left, this is the left texture, and for right, this is the right texture. Okay, and then what we need is the information about when the direction of movement for our ghost have changed. So let's get back to our ghost, because here we get the information about the direction. And let's see what can we do with that. Basically, we need to change it every single time that that the velocity changes. Right? Yeah, that seems correct. So let's start with direction and set it to null. And then in our process, or even, yeah, in our process. So let's create a scope variable, current direction, and let's calculate this. So if we don't have the access to velocity, and it might not be applied correctly yet. Okay, cool. Well, no worries. We'll just do this here. And maybe even to simplify this, we will say calculate direction with new velocity. Let's create a function for that. And let's say what do we need? We need that scoped variable, I think. And let's do if new velocity x is greater than 1, for example, but basically greater than 0 should be good too. Current direction is right, else if new velocity x is greater than, is lower than 0, then we're moving left. So current direction is left, else if new velocity y is greater than 0, you can say current direction is down. Else if new velocity y is less than 0, current direction is up. There's something wrong here. No, it's correct. Okay, so now we know that we have the old direction and new current direction. So if current direction is not equal to direction, so there was a direction change, we can say that direction is equal to current direction. And in that case, we can just need to create a signal, because we need to inform our eye sprite about direction change. So let's call this direction change, and it has a current direction parameter, which is a string. Cool. And then we can just say direction change, emit, and pass the value of direction. Okay, cool. And now we need to connect to that signal from our eye sprite. So here already I can say get parent, cast it to ghost, direction change, connect on direction change. Perfect. Function on direction change, which will get the direction as a string, right? And I can just say, what can I say? Self texture, and or just texture. I should be able to update this, right? Direction, lookup table, direction. Yeah, let's see. Yeah. Okay. So every single time that we calculate that there was direction change, we get one of these as a direction. So instead of writing another if, I can just pass this as a key and read the value from that. And often this is a very good approach whenever you want to simplify complex match, switch, or if cases, whenever you would like just to read some value based on another value. So let's see where that works. Oh, cool. It doesn't display anything. Yeah. Let's see. This looks correct. So let's see what the problem is. Oh, it's my bad because of passing the wrong values. We need to switch those to 1, then -1, or even any minus value would work. But -1 is gonna be good, and then also here -1. Let's try this. Still no eyes showing. No. Let's try and print current direction. Up, right, down. Okay, so this seems to be working correctly, but let's see what's the problem here. null, 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 null. Okay, okay, interesting. Let's see why we cannot read that. I think I know why. The problem is that we're using the exported variables and we are initiating it here. So, but this is initiated before like the data from the editor is being read into a script. So we need to add already. And now, perfect. We have our eyes moving with our ghost. So yeah, this is pretty much done. Everything seems to be correct. And in the next section, we will work on adding a timer to time out the scatter movement and start chasing our Pacman. Yeah, let's do it. Okay, so in this section, we're gonna focus on the next state of our ghost, which is gonna be chasing the Pacman. So to keep things nice and tidy, I'm gonna create an enum here, which we can use to set the ghost state, because our ghost can be in different states. What we could use is a state machine pattern. Maybe I will record another video about actually refactoring this code to using the proper state machine. But for now, let's just focus on our ghost state. So he can scatter, which we already handle, and it can also chase Pacman. So here I can create another variable, and that's gonna be storing the current state. Right? And that is gonna be of type ghost state. So whenever we call the scatter, we'll set the current state to ghost state scatter. Cool. Now, how should we handle switching from scattered to chasing? And we can do that after some time by using the timer. So let's add timer here. Let's name this scatter timer, and I'm gonna set this for 8 seconds, and I'm gonna set this as one shot, so it's gonna only run once, and I'm gonna get the reference to it here, and whenever we say scatter, we're gonna start the timer. Scatter timer start, and we need to get the reference to timeout. So yeah, already we could do we can just find the timeout, connect, and in Ghost, let's connect to that. And on scatter timeout, what should we actually do? We should call the function called, let's call this start chasing Pacman. This is descriptive enough, right? So let's write this, start chasing Pacman. Cool, so we should definitely change the state. What should we do? We should change the state. So current state should be ghost state chase. That's one thing, right? Then next thing, we can call Now it's one time only, so we don't need to call the stop. We need to set the new target position. So navigation agent, target position, and to do that we need to have the reference to Pacman. Right, so we could do export for, let's call this chasing target to make it more generic, and it's enough for it to be node 2D. Right, so and so if there's no chasing target, you can just print, can you get like error printing, print no chasing target, chasing will not work. Okay, cool. And then I can say that target position is chasing target position. Okay, and that's gonna be good, but only for a second, because we need also another timer that will constantly update the target position, because we're moving as a Pacman, right? So let's use our wonderful paint, right? We have our ghosts, right? And then we have our Pacman, and we set the position for the ghost to move to a Pacman, right? But then the Pacman moves to a different position, right? He, for example, moves here, and the ghost only knows the last position that we provided, right, when we started chasing. So in that timer, that will constantly track and update the position of Pacman, right? Like, I believe 0.25 seconds for every call should be good enough. So let's add another timer. Let's call this update chasing chasing target position timer. Cool. It's not gonna be one time off, so we need to remember, and 0.2 should be enough. That should work. Start chasing Pacman. Okay, so we have to also plug into the timeout here, and what we will do is we will simply say navigation agent to D, target position is equal to chasing target position. Okay, and then on position reached, it will be different, basically depending on our state. So if current state is equal go state scatter, then this is correct, right? So maybe we could actually encapsulate in a function right? So let's create function here, scatter position reached. So just call scatter position reached. And we need to fix our indentation here. Cool. Else, if current state is go state phase, we should say phase position reached. And for now, punk. For now, it's just gonna do, let's say, print kill Pacman. Okay, that's cool. Yeah, anything else? I believe that just to make it easier for us to test, let's change that to 3 seconds for now. This will be updated. Yeah, that looks good. Oh no, it's not gonna be good because we have to go to main, find our red ghost and set the chasing target to be player. Now it's gonna work, so let's see. Yeah, it's coming to me, but I'm gonna change my position. And it's not going to work. Okay. Let's see why. Okay, so what we are missing is, of course, running our timer in the start chasing Pacman function. And then, as you can see, it's gonna work perfectly. And then you can see kill Pacman in our console. We just get rid of rest of the prints. Yep, get rid of that. Let's see. Here there is no print. Is there any here? We can get rid of that. And probably in our Pacman we have something. No? So this is ghost eyes. Okay, I believe that's it. Yeah. Okay. Let's test this again. I am crashing. Oh yeah, this is going to be correct. So yeah, this is our chasing state. And next thing that we should handle is probably the state where the ghost is running away. So yeah, let's handle that in the next section. So next thing we would like to do is to implement the frightened state of our ghost. And this process is very complex, consisting of few steps. So the Pacman has to eat the big pellet, and it will give him the ability to eat ghosts. And ghosts should start running away from Pacman. And how we're gonna achieve that is basically we will pass the information from Pacman to our game state manager, and that game state manager is gonna inform all the ghosts that it's time to run away. And as they run away, they will be picking random empty cells in our tilemap and trying to direct themselves to it. I believe that the running away algorithm for the original game is definitely more complex than that. Maybe even, again, each ghost has its own behavior when it's running away, but for the sake of the tutorial and to try to keep it as concise and simple as possible, we'll stick to that. So let's see, what should we actually do? We have our pellets, and in that case, if actually what we could do is we already have the information about the pellets here, and we are listening on that. So to keep things simple, what we could do is go to the code and actually say, let's extend this, should allow eating ghosts, boolean, and should allow eating ghosts, oh, not boolean, but bool. Cool. Let's just emit that alongside this. Okay. And then in pellets, we know about that, right? So let me think. We could get the reference to ghosts here. And yeah, we could just reference ghosts and trigger the state change. Right, but also, is that correct? Because it's gonna work, but having that direct reference between pellets and ghosts, I'm not sure whether I like this. So yeah, but I guess this is fine. This is fine. Okay, so I'm gonna just do this. Or actually, can we make it smarter? We can, because each ghost will gonna be of class ghost, so I could just do export var ghost array. It should be type array of ghost. And the question is this going to work? Yes, ghost array. Let's set it to 1 for now. 1 for now. Then I can just pass the reference. And yeah, on palette eaten, if let's get here, should allow eating ghosts, which is boolean. If should allow eating ghosts, we can just map through this array for ghosts in ghost array. I can just say ghost. I'm gonna say right, let's say frighten or run away. I guess frighten. Right, or be scared or something. Let's just call this run away from Pacman. That's the most readable thing I can think of. Okay, cool. So what should happen in that case? Let's go to our ghost and let's think about this. So func run away from Pacman. Cool. First thing first, we're gonna change the current state. And I'm gonna say this is going to be run away. Go state run away. Okay, and then we have to check. First, we need to stop our timers, right? So stop timers, meaning navigation, no, update chasing target position timer stop, because we're running away right now. So this is first thing. Then this can happen also during scatter. So let's see, scatter timer also stop. Okay, this is good. We now have to, what we have to do is find empty tile on our tilemap and direct our ghost to it. So to do that, go open our tilemap, and here we can find custom data layer, and I'm gonna add, this is like custom data that you can add to your timemaps, which is really crazy cool and crazy useful, as you will see. I'm gonna create is empty data layer, and the type's gonna be Boolean. Okay, and now if I go here, I can find the custom data, and this is the first layer, right? Just like here, because that has 0 index, and I can trigger on, right? And you can see that, and also all of these should be, can I start multiple? No, all of these should have this turned on, right? Because these are empty layers, meaning they have no wall and no obstacle. Perfect. So now I have to create a simple script in our tilemap. Call this tilemap, and what we need is script that will allow us to return the position of empty cell. So let's do empty cells. So get all the cells. I can go get use cells 0 for the layer, and for cell in cells I can get data, custom data of each cell. Well, actually that should be tile, but you know, that's fine. So it's gonna be get cell tile data. Okay, if data get custom data is empty, custom empty cell push front cell. Cool. And then I can create another function, get random empty cell, which is going to return to global, a map to local, custom, empty cells pick random. Cool. So that's you have to find this translates the cell coordinates to local space, and then we need to translate it to global to get the global position, and by picking the empty cell we will get the get random empty cell. I believe that's going to be position actually, because to global returns vector 2. Yeah, okay, cool. Documentation is helpful as ever. So in Ghost, I need to get the reference to a Tilemap, and I have it already because I prepared myself, and I have the reference, which is perfect. And then here during runaway, I can just say var empty cell position is Tilemap. Do we cast it? I don't think we need to get random. Oh, it's not going to work because we have to add, let's say, maze Tilemap, and then in Ghost, that's not a class, that's a class name. Okay, and here I can just say maze Tilemap, and then here I'm gonna get my autocomplete. Cool. And then I can just say navigation agent target position is equal to empty cell position. Okay, but then I also have to handle that case in our on position reached. This is pretty basic because current state is equal to ghost state run away. We can just call this all over again. Okay, so this is good, I believe. The only thing that we also have to add, because there's a duration for the frightened state. It's like, I don't know, 10 seconds or 12 seconds or something like that. So in our ghost, we also need to add the ability to disable that. So let's add timer, call this run away timer, set this to one shot. Let's give it like 8 seconds. And we will need the reference to it. Right, let's get the reference, and we need to trigger it once. So if runaway timer is stopped, then run away timer start, trigger it once, right? And then we need to connect timeout. What should happen? We should it times out. It should be running once, and on the runaway timer basically we just call a chase. Or no chase, but how do you call this? Scatter. Start chasing Pacman, right? That's how it should work. Yeah. Okay, let's try this. Okay, so all is good. I can see that now I'm being chased by the ghost, but I'm gonna eat it. And yeah, now it's trying to run away. And then after some time, yeah, now it's chasing me again. Let's wait here. Yeah, cool. Perfect. What all we also need to do is we need to basically change the color of and the looks of our ghosts, right? So in animation player, let's add new animation. Call this running away. It's gonna be similar to moving, so the duration is like 0.5. Yeah, the duration is 0.5. We're going to loop and we're gonna change the body sprite, texture, insert key, go here, change to 0.25, and that's gonna be goes vulnerable, and here it's gonna be blue. Okay, and then let's think about it, because if we run away from Pacman, we need our animation player to trigger also once animate. Do we have the reference here? No, we don't. How should we handle this? Because we have the reference here. And we will also need the reference there. Okay. Well, there's no other way around it. Let's do it like this. I'm gonna say run away. That's gonna set the self modulate to color white, because we don't need to change the texture or give it any kind of color. And we will say animation player play running away. But also here we need to hide the eyes, right? Because as you can see here, it has the eyes in the texture. So hide, gonna do self hide. Hide eyes. Can we name it like this? Okay, cool. And that's also, we need to bring it back, so show eyes. And basically we don't need this. So okay. Let's see. This looks like it's correct. So in our ghost, we need the references to sprites. Okay, and then here we just need to say body sprite. Oh, it's yeah, this is custom function. If we want to get this autocomplete, we need to add the class name. Body sprite. Class name ice sprite. Cool. This should be enough to get the autocomplete going. So now let's just say as ice sprite, as body sprite. Going back here, run away. Now we have autocomplete and ice sprite, hide ice. Cool. Right. Okay. So let's try. Okay, it should be running away. Okay. The problem is we have to obviously bring it back once the timer runs out. So ice sprite show ice, and then basically here we need to let's create a function move. Let's start it here and let's call this here. I mean move. And we don't need that comma, of course. And then in Ghost, I can just say body sprite move. Cool. Let's try this again. It's running away. It should be for 8 seconds of choosing random tiles. And now it's back to chasing me. And if I trigger that again, perfect. The one thing that is missing though is, of course, the fact that in original game, the ghost is blinking when it's close to end of the Pacman superpower. So when the time when the Pacman can eat ghosts ends, the ghost starts blinking, right? And then we have to figure out how to do that. This is pretty easy. What I can go and do is I can set the variable here is blinking, right? And what? I can measure the time during the process, right? So if runaway timer is stop is not true, so the timer is running, and the frightened runaway timer time left is less than let's say runaway timer wait time, let's cut it in half, and we did not trigger blinking yet. Set we could just say start blinking. Okay, and here we will definitely set is blinking. Oh, we don't even need the is blinking variable, not that I think about it. Right, let's write the where is it? Oh no, we need it as a flag. Do not trigger this over and over again. Okay, cool. So here we will set the is blinking to false, and we'll also initiate it as false. And then we need to write start blinking function. Start blinking. And basically it's gonna get the body sprite and say start blinking. And in our body sprite we'll do function start blinking, which is going to get the animation player, and we'll play blinking animation. So let's create that. It's very simple. We'll create new animation, call this blinking. It's gonna take 1 second. It's gonna change the body sprite, texture, and insert 1, 2, 3, 4 keys. 0.25, 0.5, 0.75. It's gonna go like this and this and this and this, and I believe I moved that. Yes, I did. 0.25. Okay, that should work. Let's see. And it's stuck for some reason. Let's check this. Let's try this again. That was strange error. Okay, chasing me. Okay, I don't know what that was. You're blinking and now you're back to normal. Cool. So this is the running away state. The next state is we'll handle the situation when the Pacman eats the ghosts, and then the game is paused for a while and you can see the points that the player acquires in the game screen, and then the ghost returns home, right, to like restart itself. And we'll handle this in the next section. Okay, so in this section, what we would like to handle is basically the interaction between the ghost and Pacman, meaning if the Pacman is able to eat ghosts, it should then change the ghost state to being eaten and running back home. And if not, then we should actually like kill our Pacman, should like lose a life, right? So how to set it up is we need to check a few things. Basically, we have to check whether the ghost exists on the proper layer. So let's switch that to, we don't have a layer for that. Let's see. To the physics. Okay, ghost. It's gonna be like level 5. So you can see that ghost exists on level 5, and our player collision has to interact with the wall, the small pellet, big pellet, and the ghost. Okay, see if everything is still working. Yes, it is. Okay, cool. So we have that set up, so we can go ahead and click on area 2D, the root of our ghosts, go to node and find body entered. Okay, and let's override this in our main script. Because we know that the only body is gonna be a player, so basically we can say player body as player. Cool. And then based on our state, we'll do two things. So let's check whether the current state is ghost state. How did we call it? Runaway. Okay. If it's running away, then we will trigger the method called get eaten. It's non-existent, of course. Else, if the current state is equal to ghost state chase, or this can also happen during current state scatter. Okay, what we have to do is handle the case when we die. So we should definitely let's find our timer, because if the Pacman gets eaten, we will stop the update chasing target position timer, and we should be able to like die. Our player should die, and then probably we would like our ghost to do what? We could tell them to scatter, and we could take the scatter timer and set the wait time to be like ridiculously high, so they're gonna just scatter every single time, like for a very long time. Okay, and that's it. So we need to write get eaten, and we have to create die method. So maybe here let's do get eaten. For now we will pass, and also here we'll create die method, and we're also gonna pass for now. Okay, so let's think about it. What should happen to our ghost when it gets eaten? In a game, what happens is that we only display the eyes of our ghost, and it returns back home. It goes home and then immediately goes out chasing the player again. Okay, so we still have to do it step by step. Oh, and also before that we display like the information about the amount of points for our ghosts, right? So, and I believe that the base is 200, and then every single ghost we eat when it's frightened, we bump that up by 200. Okay, so there's a lot to unpack here actually. So first thing we have to do is to do body sprite hide. Okay, we don't want it to show anymore. Do we have something to actually... No, we can just do hide there. Then we should have some label here to display the amount of points for a ghost. So let's see. Let's just add one. Add card node label. And let's see, how should we size? Let's do 200 for now. Let's do center, texture, nearest, theme, quick load. Do we have a theme for the text? See, let's open UI, game label as a theme. Let's save it as a label theme, and then we can reuse that theme by going to quick load, label theme. This is pretty much too big, so let's go to font sizes, change it to like 20 or maybe 16. Okay. Cool. Need to position it like in the middle or maybe above. Maybe let's make it a little bit smaller, like 12, and make it pop up above. Cool. Yeah, and we need a reference to this. So going back to script, I'm gonna call this point label, and okay, do it like that. So it should start hidden, because right now if we start the game, it's gonna be, yeah, you can see it always visible, right? So let's hide it. So then in get eaten we do points label show, and then like we should pause our game for a scratch second. So if you play the original game, the whole game's like freezes for a second to indicate that the ghost was eaten, and to let you read the points label, and then it pops up back again. So basically what we need to do is create a separate node with a timer, freeze everything in our game tree, and then after a second unpause it. Okay, so let's do just that. And I'm gonna create, I'm thinking, how would you like to do this? Because it would be good to keep everything separate. So maybe we will create a node and call this, let's take a node and call this points manager, and let's add script to this. Let's name it like that, points manager. And we need a few things. So points for eaten ghost, we will set this to 0 at the very start. And then we need a method let's say pause on ghost eaten. Okay, and we can just say call the score or points. Okay, and and what we'll do here is we'll say that the points will be equal to how do we do it? We need points, and let's say points for ghost eaten. So this will be like the summary of all points we acquired throughout the game, and that's gonna be the current amount of points for any ghost eaten that will be updated. So points for ghost eaten. Okay, so when we first eat the ghost, that's gonna have a 200 value, and for the next one we'll get 400, and then it resets itself to 0. Okay. What else? Oh, that's a function, of course, not a variable. Okay, and then we need to pause our game for like a second or two. So to pause the game, we could do get tree paused equals true, and then we have to create a timer and wait for a second. So we could do it in line. It's get tree create timer 1 second timeout, and this is a smart way to create like one-shot timer. And then I could do get tree paused false. Okay, and in our ghost I need a reference to let's give it a class, right? Voice manager, let's do class name point manager, and I'm gonna need a reference. Cool. So in the main I can apply that reference. Perfect. And now in our ghosts I can go to get eaten and say await points manager pause on ghost eaten, and then I can do rest of the stuff for our ghost, which is going to be let's start with points label hide. We also need to stop the runaway timer, and we need to update current status and current, so we'll add a new status, and that status is going to be eaten. So let's do just that current state is equal to ghost state eaten, and that is not going to work, and I'm gonna explain to you why just in a second. So let's eat that. Oh, and it did work, but our ghost disappeared completely, right? So this is interesting. We should probably say also ice sprite show ice, right? Because okay, and then yeah, we have the ice. Okay, yeah, cool. That actually works, but I wonder whether it's gonna work if we have more ghosts, but we can get back to it. Okay, cool. So in in the next section, we will handle how our ghost should behave when it's eaten, right? But now we should also probably can also in this section add the animation for our dying Pacman when he gets eaten. So let's go to animation player, and we will be working on the death animation. So let's create new animation, call this death. Set these to be 2.0 seconds long, and we have to close this and go to Pacman. So here we have the death. This is 1 to 11 11 sprites, and we will set the key every 0.25 second. So sprite 2D, open the texture, insert key. We'll adjust this, of course. So 0, and that should be Pacman def 1. Then 0, this is 0.2, so it should be 0.25. So let's just go through all of those. And that's gonna be this one. And let's end here by setting the final sprite. So this is our animation, and we could just do animation player play depth. Okay, let's try this. So I don't have superpowers. Oh yeah, and you can see that I am still able to move and still able to interact with pellets. That shouldn't be the case, obviously. So what I could do just here is say, let's see, get input. I can just say physics, or, oh, sorry, that's not what I wanted to do. Process, physics. How do you do this? We need to disable everything, basically. No, that's not it. Oh, it's called set physics process and set it's false. Okay, just to stop us right in the place. Yeah, perfect. And as you can see, this loops and this loops because or maybe of two reasons. Do we loop here? No. So we should also disable the collisions. So let's say our set collision mask value to be 0. No, we shouldn't interact with ghosts, so that's gonna be like layer number 5, and the value should be false. Okay, let's try this again. Let's wait for our ghost to be okay. We need to be faster than that, or set the longer scatter timer to test this. Let's set this to like 6 seconds. Let's try this again. I need him to be like somewhere here. And he now scatters indefinitely. And this is still working. Let's see. Ghost is in layer 5. and Pacman of layer set to 5, so this is going to interact. This should work. Set collision mask value. Is this maybe 4 because it would start at 0? Okay, well, that was strange. Let's try this again. Let's see whether this is re-triggering. Okay. Yeah, it keeps on happening, even though it shouldn't. Set collision layer value. Maybe it's the opposite. Okay. No, still keeps happening. Okay, I think I know what the issue is. Since we are triggering the collision on Ghost side, we need to disable the collision here. So I can just say set collision mask value 1 to be false, and then I don't really need that. Let's try this, and now our collision should trigger once. Yeah, perfect. Okay, so we have that handled, and in the next section we will handle our ghost being eaten and going back home. Let's move on to the next section. Okay, so in this section we're gonna handle our ghost being eaten, right? So if we take this and this, now our ghost should pick up the speed and return to home, maybe go bottom up, and then go back to chasing our Pacman. So let's see what we can do about that. We have the get eaten, right? So basically what we will do is in our main, we would like our ghost to go back home. So I'm gonna go to movement targets, red ghost, and I'm gonna add a child node. I'm gonna say home. So it's gonna be the wrapper for home targets, and I'm gonna add 2 markers. And I'm gonna say it's gonna be bottom, and maybe we would like for him to go here, and then let's copy that and say top, and maybe go here. So one thing we have to check is whether our ghost is actually able to reach there. So let's show our navigation, and we can see that it's not. First, it has to be able to pass through here, and I can see that this is not correct. So let's go to the tile set, paint, navigation, and I can see that I should paint that part with different tile set. So let's change that. Tilemap. Why is it not painting now? Okay, now this is correct. It can pass right through the middle. It's perfect. And here we have the problem, which is the fact that this is not navigable, if that's even the word. So our ghost cannot move through here. So let's go again to tile set, and let's create alternative tile. Choose this navigation. Why is it not showing? Excuse me. Something went wrong because it has the navigation. Why is it not showing here? No idea, but let's say, now it's showing. Cool. Reset to default shape, so it's all filled with the navigation. Let's do the painting. So let's do this and let's paint and fill that navigation area. And now our ghost can move through here. Cool. We need to add those navigation movement targets to our red movement targets. Let's disable that. So let's see, at home targets 2, and the first one actually for him to go down then up. So I'm just going to say first should be bottom and then top. Cool. Then in our ghost we have the access. Let's get rid of that. We have the access to the movement targets. So now if we are getting eaten, after that I can say navigation again. Target position is going to be equal movement target. How do we call this again? At home targets. Okay. At home targets 0. Okay, let's try this. So let's eat our power pellet. And of course it should be position. Try this again. And he goes not where he's supposed to. And why is that? Because runaway target should stop. Something's wrong. Okay, and I know what the issue is. So if you take a closer look at our navigation, we can see that this point is not connecting correctly to the navigation. So this is like, if we hide the ghost, these are not connected. So let's go to the Tilemap tile set. And this is a paint navigation layer. Do you have the one that could handle that? No, but oops, we can just add an alternative tile. Get this, set it here, and then add some more points. So edit, drag that here, drag that back, add another one. Okay, this is good. Add alternative one, flip horizontally, cool. Now we can go to the Tilemap. Tilemap and say use this one and then use that one, and with how it goes, now it's connected. Cool, perfect. So that was the issue. Save this, disable the navigation, and let's try this again. Okay, he's running away, I'm eating him, and now he's able to go back there, and he's stuck there. Okay, so now we need to write the code for the behavior whenever we reach the position. So we are in eaten state. Go state, then and we reach position. And what should happen then is we should actually point it to go to the top, right? Or basically we could actually immediately scatter back, no, chase our Pacman, right? Yes, that's correct. So what was the name of that? Run away target, run away from Pacman, start chasing Pacman. After you reach it, start chasing Pacman again. I believe that makes sense, right? So let's see. Getting eaten, you're returning back home, and you should start chasing Pacman. Cool, but we also have to re-enable the body. So body sprite show, but will it show with correct texture? That's the question, because it may be the previous texture from yeah. Okay, so basically let's copy this and create a new function, and let's call this let's call this what? Start chasing Pacman after being eaten. I love descriptive function names. Okay. Maybe here. Start chasing Pacman after being eaten. Okay. And body sprite show is not the correct function because we'll update it and we will say what we need here is the reference to a normal state or chasing state or scatter state texture. So let's say standard ghost texture. No, actually no, what we can say is just move, right? Because this is, yeah, we can just say ghost move. Okay, cool. Let's go to Pacman, go to ghost and say body sprite move. And let's try this again. Okay, it is being eaten. Oh, we need to do also do the show. Body sprite show. And that should work. Okay. Perfect. It's working. One thing that we could also add is we could update the speed here. So let's see the speed. It's used there, but we could also have like for eaten speed, and let's make this by default to 40, and then where's the oh, here's the list of methods. Ha, cool. Let's find the process. Perfect. I could say var current speed is equal to eaten speed if current state is equal to ghost state eaten, else is gonna be just speed, and we will use current speed because in original game the eye is traveling back at home when the ghost is eaten. They're moving faster than normal. Let's try this again. Yeah, cool, perfect. Okay, so we have that handled properly. Let's think about the next section. And I believe the next section will be us adding more ghosts. So we're gonna handle that in the next section. So in this section, we're gonna handle adding more ghosts, and this is something that we really have to think through because if you take a look at the original game, the ghosts can start either outside, right, like our red ghost here, or inside, right here, right? So we have to be smart about it. Let's start by adding an export variable and call this is starting at home. We could also calculate that value based on the location of our ghost, knowing that if he is in that bounce, then he's starting at home. We could also even add an area or collider to detect that, but setting that explicitly is just way easier. And I'm gonna start as false with that for our first ghost. And let's go to main, and let's actually create another ghost and let's place it. So instantiate child, gonna be a ghost. All right, we need to set the scale properly, right? 0.2. Okay, cool. Where is it? Here. Set it to 2. Set the color, and I believe the color is for example yellow, right? Okay, let's set the things that we need to set as reference. So points manager is starting at home on. Movement targets, we need to create those. Oops. Let's call this yellow ghost. We need to set the tilemap. The chasing target is the player. Okay, movement targets. Let's create these. So let's create new node here. Call this yellow ghost. Add scatter targets. So this is another node called scatter. Add another node called this home. And let's start adding those markers. So basically, I'm gonna point this ghost to move around here. So let's find a marker. We call them just, okay, yellow 1. Cool. Let's place this marker here. Duplicate. Move that one here. That one here. And that one here. Okay. And for home targets, it's gonna be bottom and top. So the bottom one, let's put it in the middle. And top one, let's put it here. Okay, we can create new resource. Call this, and it's gonna be just a resource. Call this yellow movement targets. Okay. And let's apply the script. Movement targets, scatter targets 4, 2, and let's start adding these. This is yellow 1, yellow 2, yellow 3, yellow 4, and bottom and top. Good, and we need to apply these. So go to yellow ghost, and let's get those targets. Perfect. And now to our code, because now it's going to change a little bit. So let me think. We need to change the add the ghost state, and let's call this starting at home. And we need another timer. So add a timer and call this at home timer. This is going to be one shot, and the time we can set, for example, to 8, right? And we need, do we need our reference for the, yes, we need, because we will need to start this. Okay, so let's get the reference to that. And then in our ready method, let's say we have the current state, right? And let's see, we scatter here at the start, but we should also create a function called this start at home. Okay, for now let's pass. And if start at home, no, if, how do we call this? Is starting at home. If is starting at home, else scatter. So here we will call start at home function. So if it's starting at home, right, what should we do? We should set the state to be go state starting at home. We should start the at home timer, start, and we should set the movement target, target position should be movement targets. What do we call this again? I believe at home targets. Yes. At home targets. And basically what we will need here is a simple counter. So var current at home index is equal to 0. Current at home index position. Okay, and now if we reach the position while being at home, starting at home, should move to next home position. And this is not needed actually because we handled that during the collision, so we'll get rid of that later. Let's do this, and let's say move to next home position. So that's going to be navigation agent to D. How can we write this? Basically, we can do this. Navigation identity target position is, no, we need to change the index. So current at home index is equal to current home index, and we need to switch between 0 and 1. So it's gonna be 1 if current at home index is equal to 0, else 0. Okay, and this is going to switch 1 if it's 0, and if it's not, that's gonna be 0, and it's gonna switch between 0 and 1. And navigation agent, the target position is going to be movement targets at home targets current at home index position. Cool. Yeah, and that should work for the start. Let's see. Yeah, it's gonna bump up and down, but then we have to release it, and it should scatter when the timer runs out, right? So we have the ready. Where do we set up the timers? Probably, oh, we have the start here. So we need to connect to the timeout. Timeout, connect on at home timer. Timeout. Or basically, can we just do scatter here? Because it's one shot, so the timer gonna stop. I think yes. Let's see. Okay, yeah, it scatters. And then it should switch to chasing me. Right, and it does. Cool. Perfect. So yeah, now we can just add more ghosts. It will start scattering, and then it's gonna switch to chasing me. Perfect. Cool. So let's add all the ghosts. I'm not sure. Let's see. What are the colors of the ghosts? The yellow, the pink, and the blue. With pink and the blue. Cool. So let's go to main. Let's collapse these and instantiate child node. Ghost. Call this pink ghost. Add another one. Blue. Ghosts. Gonna be blue ghost, and we need to add their targets. And else, they both are starting at home. We're adding the points manager, the chasing target, the Tilemap. Let's add it here too. Points manager, chasing target, Tilemap, and let's create the movement targets. So basically you can copy that and call this pink ghost, and let's say that our pink ghost is starting here. We need to bump up the scale. So his home targets are going to be here. Oh, this is should be, yeah, this is bottom, this is top. Okay, then change this to pink one. Pink 2. Pink 3. Pink 4. Okay, and we need to move them. I believe they're moving around this area, right? So that should be this. That should be here, here, and here. And of course, if you'd like to have a different scatter timers for each ghost, if you'd like to have that option, what we should just do is to export a variable here called scatter wait time, and then apply it to scatter timer as a wait time. So we can do this. Just for fun. And ready scatter timer wait time is it's right, just to give you more configuration of our node. Going back here, we need to create a resource. Call this pink movement targets. Grab this, quick load the script, set this to 4, set this to 2, and let's just assign these bottom and top. And one thing that we have to also set is the color, which is like light pink. It's probably something like this. And then blue ghost, let's change the color, looking for this very light blue. Perfect. And then what? We have to create the movement targets node. So copy that. Rename everything. And let's set those accordingly. So this is first, second, third, and the last one. Let's start with him maybe somewhere here, or you can tell them even to move across, right? It's always fun to do some changes around here. I can duplicate that. Oh, no, not that. Let's say blue movement targets. Let's clear all of that and assign blue, blue, and the last one bottom and top. Let's find the blue ghost, set the scale to 2, and let's set them here. And let's see whether this works. Yeah, we did not set the movement targets for the blue ghost. No worry, we can just grab this and drop it here. Invite index at home targets on base nil. Okay. Why? Blue movement targets. Let's see this. It looks correct to me. Let's put the booger here. Direction. Movement targets at okay. Why? Is it because I duplicated the... Is it because it's duplicated? Let's try this again. New resource instead of duplicated one. Blue movement targets. Apply the script. It looks the same. It feels the same. Let's see. Blue 1, blue 2, 3 and 4. Bottom and top. Blue ghost. Let's clear that resource. And let's apply that. Oh, this is for the yellow one. Yellow movement targets. And if you're wondering what was the issue, is that I did not supply the movement targets to the pink ghost. So let's apply this. Right now it's all correct. Check this. Check this. Everything seems to be set. Okay, so let's run all of our ghosts. Okay. Let's see, they're moving out their respective position, and let's hit the power pellet. And only one ghost, right, is changing its state. So that's a problem that we will have to handle in the next section. Okay, so in this next section, we are going to handle the case when the Pacman dies and we kind of need to reset the game. But first, let's fix that one bug. Just to remind you, if I'm going to wait until all of the ghosts are out of their home area, and I'm gonna eat the power pellet, only one ghost turns blue into the chase, right? So we have to fix this, and let's see, if we go to main and we go to pellets, here we're missing the reference to other ghosts, so let's make it 4 and let's bring red, yellow, pink and blue. Perfect. Let's try this again. Let's wait for them to move out, and now, yeah, and as I eat them, I get more. I should get more points, but yeah, I always get 200. So let's fix that too. So this is fixed. Now let's fix the points. So in our player, no, not in our player. Points manager. Okay. Pause on ghosts eaten. Correct. Points for ghosts eaten is equal to... Oh no, this is more. The problem is in the label then, right? Because we have the points label. Yeah, and what we need to do is say, before we do this, we need to say points label is equal to points manager, points for ghost eaten, points label text is equal to points manager, points for ghost eaten, and this doesn't add up because that should be 200 for the starts, and then each subsequent call should actually bump this up. So points for ghost eaten plus equals 200, right? But we need to set this back to the base value after the chase is finished. So let's see. We have a Pacman. We have pellets. Let's find this pellets manager. This is on pellet eaten. And one thing that we're missing is the information about when to reset the game. Okay, so basically we will need another node to solve this. And that should be empty node, call this game manager. I hate this name, but let's call this, where is it? Let's move it out and let's call this game manager. And we know that we have a ghost timer, runaway timer set to 8. Basically, we will need the same timer here. So let's say run away timer. Set this to 8 2. Cool, and now find our pellets. We have the ghost and they have run away from Pacman. Let's see. Because maybe there's a better way to solve this, but let's find runaway timer. Yeah, it's getting stopped here. That would be the problem. Okay, cool. So basically we have a game manager and do we even need this? Maybe not. Because I can just say here. in pellets. If should allow eating ghosts, then we just create a timer. So get 3, create timer for 8 seconds, and we can do timeout, connect, and we can just create a function here called reset points for ghosts. And let's pass it here. And then I can just call get the reference point manager. And when that times out, points manager reset points for ghosts. All this, and here in the points manager, I can just write reset points in the points manager. So here I can just write reset points for ghosts, points for ghosts eaten is equal to yes, and that should work, I hope. Okay, so let's allow all of the ghosts to go out. And it says this, so I'm eating a pellet, and for the first ghost I should get, yeah, that wouldn't be correct. We have to parse the string, so that's gonna be %d %. Okay, let's try this again. Okay, I think first there's 200, then the second one, and let's try eating again. And now I'm dead, but this wasn't really visible that much, so let's try just printing that out. So now that should pop up in the console. Okay, 200, going for the next one, 400, 600, and 0 because the timer ran out. So that was not correct. 200, 400, 600, 800. Okay. So there might be some issues with miscalculations there. Okay, so we have that out of the way. I'm not going to fix that little bug with the miscalculation that is long as it is. Okay, so we have that. Now we have to handle the situation where our Pacman dies, right? Because the simplest way to solve this will be just get 3 reload current scene, right? That would be the best approach, but the problem we have with that is that, yeah, as you can see, there's no time to display the animation, and also the problem is that all the pellets are getting reset, so not the good approach. So what we will do instead is we'll let the def animation play. So let's go to animation player in our player, go to node and find animation finished, and let's connect to that. And then it's gonna be animation name if animation name is def, right? We can basically reset the game. So I'm gonna do this. I'm gonna say we're gonna emit a signal called player died, and we are going to emit that signal. Okay, so that's one thing. Second thing is we have to reset the location of our player, right? If we go here to our main, you can see that he should start in here, and then our goals should respectively start in those positions. So actually in our movement targets, these are not movement targets per se, but I think it's smart to keep everything in its right place. So I'm gonna add a child node, and I'm gonna call this player, and yeah, player, and I'm gonna say we're gonna add a marker, call this starting position, go back to player script, and I'm gonna export here. Oh, that should be below, I think. Yeah, we're gonna export that. So node to D, and now I can pass this. So let's go to 2D and see. The starting position of our player should be the same. So it's -1 to 1, 6. Let's set that to -1 to 1, 6. And we have a reference to this. So I'm gonna say reset player. And let's write that function maybe here. Reset player, and we're gonna do two things. So we're gonna say that animation player should play default at the start, and also we are going to say that position is equal to starting position. Okay, and now we should also call the reset player on ready. Cool. So let's see what happens now. I play the def animation and I'm back here at my place. Okay, so now I also have to reset the ghost position and their state. So for all of our ghosts, we're gonna add the starting position. So red ghost, starting position, marker to the starting position, and the ghost blue, also starting, marker, of course, starting position. Perfect. Let's find these and give them the proper values. So bring that down. Let's find the ghost. Red ghost. Transform 0 -72. So 0 minus 72. Okay. Then we also have yellow ghost. Yellow ghost has position of 0, 0. Cool. So I'm assuming this is correct. A pink ghost. 50 and 0. Pink ghost. 15 and 0. And blue ghost. That's gonna be different. Minus 43, minus 5. Minus 33, minus 5. Perfect. Okay, so that done. We have to go here and export that variable. Export var starting position node2d. Again, we could use marker2d, but marker2d is inheriting from node2d, so it's all fine. And now let's assign those references. So here, let's go starting position, a yellow ghost, pink ghost, pink ghost, blue ghost, blue ghost. Okay, cool. Let's see what else we have to reset for our wonderful ghosts. We have this setup, right? And in the setup, I can say position, starting position, and basically that's it. So resetting our ghosts would be calling a setup on them. So let's see. I could add a simple script here and then give it a reference to a player. And on function ready, say cast this. Get children as array of ghosts or ghost in ghosts. Basically, yeah, that's gonna be correct, but we have to do it differently. So player died, connect, reset ghosts, reset ghosts, and now we can do the resetting. This, and then I can call ghost setup, and that should work in theory. So let's wait until more ghosts pop up from their homes. Okay, let's crash into one. We play the death animation and we reset almost everything, but we cannot move. So in Pacman, in reset player, what is missing is process set, process no, set physics process to true. Okay, and now I'm gonna crash and it resets my ghost. So let's test when more ghosts pop up. And they just scatter, and now we're resetting. Perfect. Cool. But there's also another thing we have to do. We have to set the next movement direction to vector to 0 and movement direction to vector to 0. Right? Correct. Okay, and in our goes, we call setup just to be no, this is correct, this is correct. Yeah, this all looks correct. Do you have any errors? Oh, so we do not need to. Oh, this is because we are resetting that once again, but we can just move this then to ready. Okay, let's see, and now we shouldn't have more errors in the debugger. No, and okay, Pacman stays in the place until user presses a button. Cool. So this is almost everything that I wanted to achieve. Again, the tutorial isn't 100% perfect, but we will also add sounds in the next section and then add just a tiny bit of UI. So yeah, I guess I'll see you in the next section. See you. Okay, so now to add the sound to our game. Let's create a new node here. It's gonna be empty node. Move it here and call this sound players. And we will add audio stream player to the 4 times, naming them Chomp sound player and it ghost sound player and power pellet sound player and Pacman depth sound player. Okay, and let's go to our sounds in assets folder, and for Chomp sound player we have the Pacman Chomp. For it ghosts we have Pacman in ghosts, it ghosts. Power pellet is Pacman power pellet, so just put this into stream. And then Pacman dev is Pacman dev, of course. Okay, perfect. Now we have to play those in the right moments. So let's be smart about this and start with the Chomp sound player, right? So basically this should be played in pellets because we have on pellet eaten method here. So let's just get the reference here and let's do this like that. On pellet eaten, so if Chomp sound player, let's see, this is playing, no, playing. If it's not playing, we'll play the Chomp sound. Okay, and you can see how the sound already brings game to life. Cool, right? Way better. Okay. Now in Pacman dev, we also need a reference here. So that's gonna be Pacman dev sound player. So let's export the reference. This is Pacman dev sound player audio stream stream player 2D. Cool. And we're gonna just say play. I mean Pacman dev sound player play. Go to main, pass the reference here. Let's try this. Perfect. Then we have the power pellet sound player and it goes sound player. So power pellet, let's go to our pellets. Where is it? Pellet manager. If should allow eating ghosts. So let's go back to main and we will start this in our pellets manager here. Oh, we of course need a reference, so let's get that. Pacman. Oh no, that's the wrong player. Power pellet. Yes. Power pellet sound player play. And we know that we reset points for ghosts whenever the power pellet timer runs out. So here we can just do power pellet sound player stop. Okay, let's try this. Okay, cool. Oh. Okay, that was strange. Let's try this again. So it seems we have some kind of error, but let's finish with the sounds for now. Ghost eaten. So somewhere around here we should get eaten. Okay. So here we're going to export a sound player. Again, export ghost eaten sound player. Audio player 2D. Find this await, and here we're gonna just play this ghost eaten sound player play. And let's give the reference to our ghosts here, and this is going to be it ghost sound player here, 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 and here. Okay, let's try this. Okay, cool. Okay, let's see. Oh, I can see that the reset is not working correctly, but because we are chased by the only eyes of our wonderful ghost. So let's fix that error. Let's go to setup, and here we have to make sure that Eyes sprite. This is set to show eyes, and then body sprite is set to move. Okay. So let's try this again. That. Okay, now we're dying because of that. Okay. We're still being chased by the eyes alone, right? So why is that? Okay, so there's one possible bug that we can fix. So here, let's, on our ghosts, let's actually do another export and say starting texture is equal to texture 2D. Okay, and here on ready we can say body sprite texture. That's how it's, yeah, that's, you can say starting texture. You can or basically we need to, no, that's not going to be texture. Starting texture. And whenever we call move, we say texture equal to starting texture. Okay, and now going to ghosts. See that we don't have the starting texture, so we can just say it should be this and this and this and this. Okay, let's see where that helps. Everything seems to be normal. Let's trigger that. Let's eat some ghosts. Okay. So there's still some kind of bug. So fix number one is we should, because some ghosts are starting at home and the red isn't, but we should also only tell the ghost that isn't at home to start running away from the Pacman. So here in the pellets, in on pellet eaten, I can, in our loop, I can just add this check to make sure that, for example, right now, when the other ghosts are at home, only that one runs away. So that's the problem number one that we can solve. Okay, cool. Now we have that problem with the 0, right? So the points counting that has to be solved. So I'm thinking the problem is here, and we have to write a smarter way to actually know when the ghost runaway timer stop. But we have a ghost array, So what we could do is do a simple trick and say, let's add a signal and say run away timeout. And on the runaway timer timeout, we will just say run away timeout emit, but also where we stop runaway timer. So here, yeah, also here we'll say run away timeout emit, and then in main, in pellets, we can say for ghost in ghost array, let's say ghost runaway timeout, connect to on ghost run away timeout. Okay, and let's write that function. And we need to basically count how many times the ghost has been eaten, and we know that each ghost can be eaten only once. So eaten ghost counter set to 0, and if let's say eaten ghost counter plus equals 1, if eaten ghost counter is equal to ghost array size, then we know that all timeout run out, and we can say points manager how did we call this? Reset points for ghosts. Reset points for ghosts, and we can say eaten ghost counter is equal 0 to reset the counter. And yeah, that should be it, right? Let's try this. Oh, I died. Okay. 200, 400, 600, 800. Okay. Oh, and we need to stop the sound player. Cool. Let's try this now. 1, 2. Okay, perfect. One thing though we need to fix is the label of the points. It's not really visible as much. So let's go here to the, let's show this. And what we should add is some kind of border or something like this, or maybe a shadow drop. Outline size, perfect. Let's do 3 pixels. Oh no, let's do 2 pixels. And can we change there's a font, there's a default font and scale. Okay, how about outline color to be black? Should be good. Let's try this now. Oh, we have to hide it. Okay. Okay, let's try this. 200, 400, still visible. 600. Okay, and now we... Okay, so another thing we have to fix is whenever Pacman dies, we have to stop the pellet sound, right? So have a Pacman, he emits the signal, right? And the sound player should actually be stopped here if it's playing. So we could do just direct reference. So pellets manager. Oh, it doesn't have a class, right? Right. Okay, and here that's gonna be PowerPoint sound player stop. Okay, that should solve that issue, and we can test it, right? Because right about now the other ghosts should pop up. Oh, PowerPoint sound player on base needle. Yes, because we did not pass the reference. So as you can see, there are many bugs even with such a simple game in theory. Okay, let's go for this. Should return and then let's crush it and die. Okay. Perfect. Cool. 0. Okay, that was strange because I think we have another bug. So let's grab this. Let's eat the ghosts. And let's, come on, let's try this again. Zero, 200, 400. Try die. Okay. Okay, so there are other things we have to fix, which is after setting the resetting the points. So points manager, that should be reset to 200. Okay, this is the base value, so we could do just const like base points for ghost value, and use it here and here and here. That's way better. The other pack would be, let's check that. Another pellet. Okay, so this continue counting points, cool. Okay, so this is getting played multiple times over the def. So we have to go to Pacman, sound player, and do if Pacman def sound player playing, then play. Okay, I believe that solves most of the bugs. Let's try this again in a second. Okay. Let's maybe have that process repeated. Let's stay here. Let's see. I saw the ghost passing through me. Okay, so I believe what we're missing is ghosts in setup. What we need is to re-enable the collision mask, set it back to true, because we disable it when the player dies. Let's see. See where we do this anywhere else. No, that should be it. So let's die, and we died from the red ghost, and let's try this again. Yeah. Okay, so what we were missing was that collision mask reset in setup. Here in ghost script in setup function, we need to reset the collision mask. Okay, cool. So yeah, this was fixing bugs and adding sounds, and the last step is to manage the life of our Pacman, because in the base game the Pacman has 2 lives before the game runs out, and then adding some kind of simplistic UI. So we'll do this in the next section. Okay, so we need to handle the death or our player, meaning there can be possibility to actually lose the game. So go to Pacman, and I'm gonna export a simple variable, all these lives, make it int, and by default I'm going to set it to 2. Whenever we die, I'm gonna say life is equal to minus equal 1, and if life is equal to 0 after that, but maybe after we finish after we finish playing the animation, I'm gonna say signal. Maybe you can simplify this. So player died, and pass that information here. Right, so player died and pass the lives. Okay, and now somebody else will decide what happened when we reach a certain level of lives. Okay, cool. So we will reset the player only if basically we can also push that down. If lives not equal to 0, then allow us to continue the game. Else we'll handle that in the UI. So about building the UI, it's gonna be very, very simple. Let's go to the main, collapse that, and create new node. This is canvas layer. Let's call this UI. Cool. Oh, we have a UI already. I'm dumb. Okay, open this and let's see what we need to add. So we have the margin container and we have that. The center container. Let's add a hbox container in margin container. Let's move it. Can we move it up? Yes. And here I'm gonna just add 2 labels. So label, I'm gonna call this life count label, and add another one, and I'm gonna call this game score label. Game score label. Perfect. Let's arrange everything. First, I'm gonna say 1 up here, and then here I'm gonna say score is equal to 0. It's not very visible, 0. So we have arranged everything. This is, wait, is this hbox? No, it should be vertical. Change type, vbox. Let's see. Yeah, vbox. Okay. Now it's better. Let's change this to vbox container. And let's apply the correct font. So find the theme, quick load, cool. Do the same here, theme, quick load, perfect. And now we have to go to our code and get all the references that we need. So let's access as unique name, both here and here. Then I can drag this, and because I have that unique name, I don't have to traverse every single level of node with that slash back names. I can just have the naming simplified. Cool, and then let's write some functions. So I'm gonna say set lives, and I'm gonna say live count label text. It's gonna be %d something like that. Live, okay, and we will also check if lives is equal to 0. So we're gonna call the game lost function. Let's do game lost, and let's just call center container show. But first we're gonna say game we're gonna need a reference to game label. No worries. Let's add a unique name. Get this, and I'm gonna say game label text. It's going to be game lost. In that case, we're gonna change it to game 1. And also we need set score function. So set score game score text is equal to score score. Okay, that's pretty much everything we need, but of course we need to call those functions in the right places. Game score label, cool. So set score, it's of course score as here. Okay, now it's working. Perfect. So let's start. In Pacman, we need the reference to UI. Do you have it already? No. So let's do this. Just make sure this has a class name. Perfect. Export. UI is type of UI. Set that reference here. Then in Pacman, I can just call UI set lives to lives. Yes, we could also listen to a signal in a UI and have the reference of a player heard. So it's just your choice whether you rather have reference to UI in a player or reference to a player in UI. Both are good. Cool, but we have that handled. Then next step is going to be setting the score. So in pellets, now in points manager, you have to have that, and whenever we pause on ghost eaten, we also need a reference to UI here. I can just say UI set score points. Okay. So we have that handled, and then here we have UI game 1. Okay, let's see. And I'm going to die. Okay, and it doesn't change anything. Let's check about points. Okay. Okay, this is counted properly. But that does not change. So let's see in our UI. Oh, basically what we have to do is on ready call UI set lives and set it to lives. And this is on ready, but this has to be higher up in hierarchy, so we load the UI node first in the tree. Okay, and now if I die, yeah, that changes. Let's, okay, we still cannot, yeah, see, I died and we still cannot collide with the red ghost, so this is still a bug. So let's see. Are we changing something here? Oh, but if I take a look at the ghost and let's go to collision. Okay, this is correct. But what I can do now is crash, go to remote, ghost, red ghost, and see that the collision mask isn't set after all. So let's go to ghost. Set collision mask value 1 true. Should be correct. Oh, he's not getting reset. Okay, so let's go to Pacman, and the problem should be here. If flies is not player died emit, so it seems like our ghost is not getting reset anymore. So let's see. Ghosts reset ghosts. Player died. So let's see whether this gets called again. Okay, it gets at the start and then it's not being called and we have an error. Error calling from signal player died. Meta expected 0 arguments but got 1. Okay, yeah. That's the issue. Let's die once. Let's die second time. Now we should have the game lost. Cool. Except for the fact that we did not reset the player, so the collision was still running. But we can just always reset the player. No, we cannot, because that will allow you to move. So what should we do instead is to say what exactly? You can just move him out of the way, saying position is not equal to is equal to starting position, and also we can say we can disable the collision, set collision layer, and the player has collision layer set to 1 false, so that nobody can collide with him. Start position. Let's try this. Okay, this disables the collision, but why? Let's go to red ghost. That's not it. This is correct for our player. Oh, that should be in else. Okay, now we have that, and now we should have the game finished, game lost. Okay, perfect. And I believe that's it for that tutorial. It's pretty long, as you can tell. It's not perfect, as you can see. Yeah, ghosts are getting stuck there when they're trying to find the Pacman after the game is lost. But you could just what we could do to fix that, also because it doesn't look too good, what we could do is on game lost, go and disable the movement of our ghosts, and they're moving through the process. So let's see. We do it in pellets. Yeah, we do it in pellets. So basically you have the reference to ghost array, You have the points manager. Okay, so basically here, what we could do is write a function, call this on Pacman died, but it should be, oh no, we have the Go script for that. So on game lost, we could go for ghost in ghost, right? We could go like ghost scatter timer wait time. We have the access to scatter timer, right? Yeah. So goes set it to very big value, and ghost. This should be. Could do this again. Ghost current state, set it to ghost state scatter. So now they should scatter for a very, very long time. And now we have to call this when the Pacman dies. So let's see. Player died, emit. Let's see. Player died. It should accept the amount of lives. So yeah. Now we need to get the reference in our ghosts. So here have the reference to player. Say player. Reset ghosts. Okay. So basically here I can get lives and say if lives is equal to 0 to this, else do that. Cool, and we don't need that then. Let's see. So yeah, I died once. And then let's wait for all the ghosts to pop up. Or maybe not. And now they should. Okay, and these are stuck for some reason. And this one is behaving correctly. So let's check the configuration here. Okay, so let's check our ghosts and their scatter targets. Red has red, yellow has yellow, which has pink, and pink has pink movement targets, and blue has blue. So it seems that's something wrong with pink movement targets. So let's get rid of those. Let's see. Pink, 2, 3, 4. So maybe resetting the movement target's gonna help. So pink, no. 3 and 4. Pink 1, pink 2, pink 3, and pink 4. Okay. Let's check this. Oh, and also probably in ghosts here, we should do is we should call ghost scatter timer stop, reset the time, and say ghost scatter timer start, because I believe this is one-shot timer. Okay, let's check our ghosts. Red ghost should have. Okay, did I reset that? Yeah, for some reason I did. Let's reassign this. 1, 2, 3, 4. Okay. Let's see. Flying away. Cool. Now I should die. Everything should reset. Yeah. Okay, they're chasing me. I die for a second time. The game is lost. And why are they freezing here? Okay, so for the issue with the ghost being stuck, what I recommend is double check the assignment targets, right? So for some reason I added starting position here for the blue ghost, which is completely incorrect. So make sure that the scatter targets for given ghosts are correct. This is 3 and this is 4. For yellow, yeah, as you can see, this is also incorrect for some reason. So let's go to yellow ghost, to scatter, and that's going to be yellow 1, yellow 2, yellow 3, and yellow 4. So that was the issue. Just make sure that the targets for the scattering phase are correct. And what I did to basically debug this is, as you can see, all of the ghosts are grayed out. Only pink ghost is like with normal font. And I went to process and I changed the mode from inherit to disabled, so that node won't be processed. So that node is basically static in the game. And that's how I was able to figure out what is going on. So if I'm going to re-enable that by choosing inherit, now I can finally close the last chapter of our wonderful game. I can die. I can die again. Right, and now basically all the ghosts should scatter indefinitely. This is working, so something is wrong with blue still. Close this and let's check the blue movement targets. It's blue 1, 2, 3, 4. Let's check the blue ghost. Let's maybe reassign those movement targets. Okay, and let's try this again. So I die. And go on, blue. He shouldn't be stuck anymore. But he is. So let's check that the same way. All right. Gonna click on all of those, go to process, do disabled. Gonna check check the targets here. These are blue. Movement targets 1, 2, 3, 4. Move this up a little bit. So let's try this again. It's going out. It's going to 0, 1, 1, 2. And for some reason he cannot reach the next movement target. Let's change the scatter time to 20 here. And let's check that again. Zero, 1, 1, 2, and it seems like he cannot reach that third target. So I'm gonna open these and let's see. Let's clear that. Add element blue 1, blue 2, blue 3, and this is the correct node. Zero, 1, 1, 2, and he's still stuck. Okay, so I found a way to fix it. Maybe it's a little bit hacky, maybe it has something to do with the navigation system in Godot, which isn't really perfect, but it's good enough. What I did is I changed the order and the direction of the movement. So blue 1 is right here. Then here we have blue 2, blue 3, and blue 4. And after I did this, I reassigned them here to the movements target for the blue movements target. And now it all seems to work fine. So let's enable other nodes. Okay. And see, let's destroy it ourselves once and twice. And I believe that the ghost should still scatter, except for the yellow. Oh yeah, because the scatter timer is different there. But yeah, like, I'm not going to fix this. I'm going to leave it all to you. But I believe this is good enough, right? And the tutorial has been long already. It has like 22 sections. So thank you for that, and I'm going to see you in the next video. Goodbye. And if somebody figures out why the yellow behaves so strangely after the game is lost, let me know down in the comment below. Goodbye.